Hello and welcome back to Engineering Design. Today we are going to link coding of the Arduino with an actual circuit using the Tinkercad simulators. First we're going to do is go to Learn again, and we're going to go to Projects, and we're going to go to Circuits just like we always do. And instead of going down and showing more, we're actually just going to start with this first circuit here, blink with an LED. So again, projects, circuits, blink with an LED. Click on that. And this is just a single lesson. It doesn't link to anything else, but it's a good starting place. So it says that what we're going to do is we're going to learn how to make this thing blink. And it's already wired for you. So if I, step one is hit start simulation. I can do that. And if I look at the timer here, and I look at the LED, you notice it stays on for a second, shuts off for a second, on for a second, off for a second. And an astute student would also notice that this built-in LED is doing the exact same thing as the LED that is wired to the circuit. So somehow these two are linked. So whatever program on this chip is talking to this LED is also talking to that LED. So let's figure out what that's all about. So we click Next, and it says that what we're going to do is we are going to connect this LED to pin 13. Now they've already done that for you. Now the cool thing about pin 13 is a special pin. It's better than all the other pins. No, that's not true. Pin 13 is the default pin. It is linked to the onboard LED. So if you tell the onboard LED to simply go on, pin 13 will also turn on and put power out. So if whatever programs, as long as we say, do it to the onboard LED, onboard just means it's actually attached to the board, it's soldered onto the board, I can't remove it. The onboard LED, pin 13 will behave the exact same way. So we don't have to say, make this and this work. We just say, make the onboard LED work, and pin 13 will automatically work the exact same way. And it says, hey, we should have a resistor. I wonder how much the resistance should be. Hey, it's 220 ohms, like we've been using in all the other programs. Who knew? So LEDs really like 220 ohm resistance. So there it is. And that's what this is all saying. So it's telling you to connect it, but it's already connected for you. And also, if you remove the resistor and just connect the anode, so power is coming, let's hit 2 and make it red. Power is coming out of 13 and going back into the ground as it's wired here. If I hit start simulation, it goes, eek, too much electricity, too much electricity, too much electricity. So too many electrons are flowing through, and that's why we throw a resistor in. Quick thing I want to point out is that it doesn't matter if the resistor is on the way in or on the way out. So I'm going to delete the out wire. I'm going to connect the resistor to ground. And again, I'm going to change the resistance to 220 ohms. And then I'm going to connect that. Hit number 1 to make it black. And let's see if that works just as well. Oh my gosh, it works just as well. So resistor placement really doesn't matter. It doesn't matter if it's on the way in, as this was originally wired, or on the way out. It will get in the way of enough electrons that the flow of electrons is just right for this LED, and we don't get that little exclamation mark. So resistor position really doesn't matter. Before or after, it's all good. And this is just telling you to wire all that up. Feel free to go through this on your own. It's amazing. Now what they're going to do is they're going to introduce you to block coding. Block coding is simply coding, but instead of using text, it uses block. So if I click on code right here, it comes out, and now the code is in cute little blocks. Yay, and it comes in families. So if I want the output, if I want to change when or how much electricity goes out, I would click on output and use one of these. Input, if I want to listen to something, as in listen to a button or something like that, I would do input. Notation. I want to tell the human something. Everything in notation, these two things, title block comment and comment, are merely talking to the programmer. The computer skips right over them. So the computer does not read, if I look here, this program blinks pin 13 on the Arduino. The computer doesn't read that. These gray blocks are completely skipped over the computer, and they're just the programmer talking to the programmer, which might be another programmer or themselves later on in time. If you learn full-on coding, you will be using comments often. Control. Control means taking control of the processor's attention. Have it wait for a bit, or repeat something a bunch, or ask a question, and if the question comes back true, then do something. So the control button is just taking the focus of this chip and pausing the focus, or making it do something a certain number of times, or ask a question. Those are the control ones. And then we have main, or math. These are just things like pick a random number, or ask a question if it's not 7, right? Or if it's, less than 10 and greater than 5, or something like that. So these are all math. And then variables allows you to create variables. But enough about that. Let's see what's going on here. What I see is it says, hey, reading this comment right here, it says, this program blinks pin 13. If I click on it, I can then kind of go over of the Arduino, the built-in LED. Okay, so that's what it does. It makes a pin blink. It makes an LED blink if the LED is connected to pin 13 specifically. And then this comment, turn the LED on high, or turn the LED on. High is the voltage level. So it says set built-in LED, so that's this LED and pin 13 to high. If the voltage is high, then the electricity has enough of a reason to actually go through this circuit and leave pin 13 and go back into the ground. And then it says wait 1 second, or 1 seconds, and then turn the LED off by making the voltage low. And if it's low, that means instead of offering $1 million, it's offering 1 pen. And the electricity goes, you know what, I don't think going through this LED and this resistor is worth a free pen. I'm not doing it. And the electricity will not enter. Then it says wait a second, and then it'll just keep looping this. It'll just keep setting it to high, waiting a second, setting it to low, waiting a second, setting it to high, waiting a second, setting it to low, waiting a second. Quick thing I want to show you is, so if I hit start simulation, we see it goes on for a second, off for a second, on for a second. We can use the timer here to prove that. And I just want to prove for just a second that 1,000 milliseconds equals 1 second. So I'm having it stay on for 1,000 milliseconds and then turn off for 1 second. And if 1,000 milliseconds equals 1 second, then the length of time that it's on and the length of time that it's off should be identical. So let's check that out. On, off, on, off, on, off. Oh my gosh, I just proved that 1,000 milliseconds equals 1 second. I'm amazing. Okay, now this is all well and dandy, but you know what? Pin 13, I don't like pin 13. Now, 13 is an unlucky number, right? So I don't want it to be in pin 13. Let me think. I kind of like, I don't know, pin 7. 7's a pretty cool number. So what if I wire it to pin 7? Hit number 2 to make it red. How do I get it? Now if I hit start simulation, this LED, the onboard LED, works perfectly. This doesn't turn on at all because, well, no one's talking to it. This pin here is lighting up, but nothing's wired into it. So how do I tell the computer, how do I tell this chip, psst, instead of lighting up pin 13, light up pin number 7? Let's go to code and see. Well, here, this block of code right here is where I say, this one right here, this blue one, is where I say, turn the voltage on high, turn the LED on high, offer the electricity a really nice prize. And but I don't want the built-in one. Well, let's go to output. So I click on output, and this gives me the family of things I can do for output, or telling the electricity what to do when it leaves. And if I right click on this, I can say delete block, and now it's gone. So right now the computer waits a millisecond, turns off the LED, waits a millisecond, waits a second, turns it off, waits a second, waits a second. So now if I hit start simulation, nothing should turn on because I never turn anything on. The onboard's off, this is off. Okay. So what about, ooh, hey, I see right here, set pin number to high. So what if I sneak that in there? And, oh, which pin is it? It is pin 7. So let's open up our code. Let's go to pin 7. And now it should turn on. It does. Wait, it's not turning off. Oh no, it's not turning off. Also notice the onboard isn't on either, because I never told it to turn on. Took that. Wait, it's not turning off because I never told it to turn off. It's still turning off the onboard LED, the built-in one, not pin 7. Oh, so if I take this and I right-click on it, it says duplicate. Whoa, notice that duplicates the whole block. That's not really what I want. I thought I'd just do the line. So let's just delete that. Uh-oh, now I have to delete them all. Oh man, I should really be careful with this duplicate button. It's crazy. So instead, I note now that if I hit duplicate, it duplicates pretty much everything. So I should only do that if I want a whole bunch of stuff to happen. But if I just want one thing to happen, I set this to pin number 7, and I don't want it to turn on, I want it to turn off. And this, I'm not paying attention to this. Let's delete that block. So now let's look at this code. I turn pin 7 on, I wait 1,000 milliseconds, 1 second. I turn pin 7 off, I wait a second. So this should work the exact same way as it did when it was in pin 13. The only difference is the onboard LED doesn't do anything. Hey, look at that, it works perfectly. Now the cool thing about this is I can get rid of that LED and ooh, upgrade. Look at that. An RGB. Now, if I remember correctly, this one is the cathode. So that needs to go out. And I hit it as 1. So now the cathode, which is the out, is connected to the ground through a resistor. And still 220. Perfect. But now I can make, I don't know, how about, I like blue. Now if I attach this, hit number 2 to make the wire red, it should turn blue. Ooh, isn't that pretty? And it seems like if I were to, I don't know, take this green and put it in, pin 2, that looks nice. Note this is also red because it's also going to send power in. All these 3 power ins only need 1 out. So that's why I put the resistor after the LED, or else if I remove this resistor here, then this would need a resistor, this would need a resistor. If I pin this, this would need a resistor. And that's why people tend to put the resistor after the LED, especially on RGB LEDs, so that they only need 1 resistor to work with the 3 different inputs. Okay, so this one, let's see, that's pin 2. And, oh wait, the green's not lighting up. That's right, because this chip only talks to pin 7. You know what I'd like? I'd like it to talk to pin 2. So now if I click on this, and I right click, and I write duplicate, I can drop it down here and just change the pin number. So now if I change it to 2 and 2, then it'll turn on pin 7, wait a second, turn off pin 7, wait a second, turn on pin 2, wait a second, turn off pin 2, wait a second. And let's see if that works. Blue, green, pin 7, wait, pin 2, wait, pin 7, wait, pin 2, wait, pin 7, wait, pin 2, wait. Oh wait, let's drag this over so we can see it. Ready? Pin 7 on, pin 7 off, pin 2 on, pin 2 off, pin 7 on, pin 7 off, pin 2 on, pin 2 off, pin 7 on, pin 2, 7 off, yakety schmackety. Okay, so your homework is you are going to get this thing to show all 7 colors. That means I want red to turn on, and then I want it to be red and blue. Then I want blue to just turn on. Then I want it to be blue and green. Then I want green to turn on. And then I want green and red to turn on. And then I want them all to turn on simultaneously. Now, if that is a bridge too far, that's for 10 out of 10. For 10 out of 10 points, you get red by itself, red blue, then blue by itself, then blue green, then green by itself, then green red, and then all 3 together. That gets you 10 out of 10. 8 out of 10 is just red by itself, then just blue by itself, then just green by itself. Much like how this does blue by itself, then green by itself. It would then do red by itself, and then blue, and then green. That would get you 8 out of 10. What I want when you take a screenshot for your homework, what I want to see this. I want to see this code. But the code's going to be way too long. It's not all going to fit on one page. I agree. It's totally not going to fit on one page. I just want to take a look at it. So give me a snippet of it. Okay? What if I zoom out? You can zoom out a little, but it's probably not going to be super legible all the way down. So zoom out a little, give me a couple of these, maybe like twice this much. Take a screenshot, send that in, and I should be able to give you points based on that. That is your homework. I wish you well, and good luck.